will be Bernard Jones, who will talk about how precisely can astronomy be of benefit to anyone.
I need to stack up the laptops for a few seconds. Thank you very much. I'm on channel. I've got to start. Can I just put mine on top of this? Yeah, the number one. So it's like that. Go on. I love PCs, they're so slow to boot up when you need them. Okay. Now, channel one. Here we go. Well, I'm a victim of all the kind of publicity that we're talking about here today. When I was 8, I was converted to astronomy, and I even cut my bicycle up and got spanked by my mother for trying to convert it into a telescope mount. And for the next 50 years, I wound up becoming a professional astronomer. I almost worked with Imre Lakatos, who was mentioned this morning. I was into mathematical logic, and I disagree very strongly with the point of view that was actually advocated in that talk about him, but we'll talk about that privately. So I'm now a professional astronomer, and about 1995, I decided to do something else a little bit different, which is to use astronomy in the non-military industrial complex. Yesterday we heard some talks, and if I talk to my colleagues and say, well, if somebody does become an astronomer at the age of 8 or whatever, and they decide to go to university and do a degree, then the question is what? And it's always answered, well, they can do lots of things. They can go and work for this, and then the answer is always something like Thales or something like this, which is not actually very useful to the wider general public. So what I thought I would do is take you on a rather different journey. I'm going to scare you at the end with equations, just to show you that things can be very, very different. I'm an astrophysicist, not an astronomer as such, but the astronomy aspects actually fascinate me. And I'm going to take you out of the world of astronomy into other worlds, like I'm going to explain to you why we have this stupid financial catastrophe and what astronomy has to do with that. And we'll see how far we can get with this. So the story is not only was I an astronomer, but I constructed an institute in Copenhagen called the Theoretical Astrophysics Center in the early 90s. I got so fed up with administration that by 1995, I decided to work full-time doing technology. So my background is basically that now I do astronomy on a part-time basis, 1 week a month, and I publish more papers in a year now than I did when I was a full-time astronomer with all kinds of committees and things to do other than write papers. And my pleasure in life is to write papers. My company that I use exploits astronomy, so this is partly a practical experiment in how to take it into the world which is not part of the industrial military complex. So you see, when I was 8 and cut my bicycle up, I became an engineer as well. We've seen this 1,000 times in different formats. Everybody has their own little graphs. And the wonderful thing about astronomy as an educational tool, and why young people should consider it as a university degree in its own right or part of a physics degree, is because in order to become an astronomer or astrophysicist, and I insist that the two are inextricably bound, you have to learn things like biology, physics, chemistry, mathematics, statistics, computation, engineering, space sciences, the list goes on. You try to become a jack of all trades while you struggle to then apply it to, it depends whether you want to do exobiology for your subsequent work or whether you want to design experiments or, like me, just invent beautiful algorithms and produce nice graphics and things and, hey, stand up and give seminars and tell people why the universe is a wonderful place and that we really do understand it. So the question is, though, when this student has done this, What next? Well, jobs are getting short, and for those on short-term contracts, the next 2 years, which are shocking in terms of the financial mess we've been put into, will mean that people will lose their jobs from short-term contracts. That is not a very good basis for encouraging people to become astronomers. Also, we have far too many astronomers and far too jobs. They've got to go somewhere else so they can go into the industrial military complex so that we astronomers can do more experiments or do something else. And the question is, what? Now, my own experience is an example of a what. And so I will just start this little story about it, because I think astronomy, astrophysics, as I say, they're bound, they're not independent, is one of the finest ways to get young people into science. In fact, the most disappointing event of last year was the turn-on of the Geneva black hole generating machine. The amount of publicity that happened, which they then showed a little blip on the screen, I thought was so adversarial to science that I just couldn't imagine. A little blip comes on the screen, a whole pile of people clap. Hey, why did we watch this? Astronomy is much more exciting, and my friends from high energy physics will hate me for saying that. So we live in a multidisciplinary world. You don't have to read all this stuff, it's just my prompt. It's like politicians, they read these prompters. I read my prompter here, and it helps you. But this is what fascinates me. It's the universe. And what fascinates me is that this is from the 2-mass survey. It looks better on my screen than it does on that screen. That's my excuse. And what you see in the universe, this is just galaxies from the 2-mass survey, over 1 million of the brightest extended sources in this wonderful, wonderful catalogue. And you can see structure in our universe. Now, on my screen, I can see it far better than on that screen, but that's low-grade technology. The view of this, you see kind of filaments and clusters and all kinds of things, and my job for the 20 years, can you believe anybody working 20 years on understanding this structure, is what I do. And I'm going to show you a little bit of art in a minute. This is what the CFA survey people have done with that by measuring the distances to enormous numbers of these objects. The blue ones are all the near ones, the green ones are in the middle distance, and since I'm totally colorblind, I can't see that anyway. And the red ones are the most distant ones. And you see the structure well enhanced. You now see these filaments and structures, and one of the tasks of astronomy has been to understand how that came about. And there's a group in Munich, led by Simon White, who have produced the world's biggest simulation. This is where the physics comes in. This is the astronomy, if you like. Blood, sweat, tears, data reduction, heaven knows what. The amount of work that goes into a project like this is quite incredible, and we have to appreciate it. But then a theorist comes along, runs a couple of billion bodies in a computer, waits for a few weeks, you have a stack of 30, 40, 50 students, and you come out with a model like that. And they say, hey, that looks like the real universe. Almost. Not bad. We're doing very well. You see all the filamentary structure and all the holes and everything. And what I've got here is something which is a more artistic way of looking at this stuff. It's done by, if it ever runs, Miguel Aragon. And Miguel is an example of a student who worked with me at the University of Groningen, where I work. And he is interested in analyzing, he's working with me to find new techniques for analyzing this kind of stuff to understand it. And he's obviously a bit of a graphic artist as well. And we viewed this as so important that in my little company, which actually does video imaging and such, we hired him out of astronomy, because we see this as useful in the real everyday world. And I won't be able to show you any detail, I haven't got time, and it's not the subject, this is an astronomy meeting, but this kind of graphic visualization is fundamental to modern astronomical data analysis. If you can't visualize your data, you can't imagine it, and you can't do anything with it. Visualization, when you've got millions of points and all that data, how do you know what's going on? You take a different view. You take a worm's eye view, a computer's eye view, and this has all been programmed actually on a graphics card, not on a main CPU process. It's done in OpenGL for those who are aficionados of this kind of stuff. So that's the kind of thing which helps us. And you can see filaments. This is from actually the Sloan Digital Sky Survey, release 4 for those of you into astronomy at all. And we found all the filaments in it, and we've made them transparent tubes in the blobs of the galaxies. A lot of people, there's big research, huge group in France doing this too. It's nicely competitive. Competition is good. The way we do things, and this is the first part of the journey from Astro to somewhere else and back again, you start off on the left-hand panel with the original, which is a pile of blood vessels, and you enhance it. The medical industry have known how to do this at some level for some time. And the bottom two panels, the left-hand side is the Millennium simulation that I showed you earlier, and on the right-hand side, we've applied the same processing to it. So Miguel improved that processing to produce the movie you just saw, and so what's happening, we borrow techniques discovered by one set of people, modify them, and give them back. So Miguel, while he's been working at Johns Hopkins, has actually also been working with medical people to analyze things like this, which is your heart and all the blood vessels in the heart taken from angiograms. So yes, astronomy can be useful in that little corner, and as we saw earlier, the public is actually much more interested in their personal health than they are in the skies above them. I can understand that, but I think the efforts that we heard about today are wonderful in trying to stimulate more interest in what we do. But this is an example of an area where Miguel might have gone into. In fact, he was offered so many jobs from Microsoft and various other people to do this. I was absolutely amazed he wanted to come and work for my little company in England. He's a Mexican, he must be mad. This is something which I'm going to go over, I was going to talk about, but since it's the last talk, I will skip a little bit. But physics today, not astrophysics today, we don't have an astrophysics today. I think it'd be a nice idea for a magazine, in fact. Physics Today is a very fine, popularized science journal in the United States, a bit like La Recherche in France. I think it's at the same kind of level, very high-level science. Now, they conclude in 2003 that a physics education is a very good foundation for careers and things, but the physics students don't know it. It's time they found out. They also concluded that most academic physicists begin and end their careers in an academic setting and have no knowledge about the careers that the great majority of new physicists will pursue. I would contend that actually applied to astrophysics as well. And the final one is that the physics faculty tend to regard as physicists only those who hold a PhD in the field and are doing basic research. That's manifestly wrong, of course, in astronomy, because we have a most wonderful pile of astronomers who make outstanding contributions to astronomy and who make outstanding contributions to the publicity of science, like the movie we just saw was absolutely fantastic for the field in general. But my punchline is that in 6 years since the article was written, nothing has changed. And I'm not sure that astronomy and astrophysics is that different. So we're teaching them the wrong thing. I've got a quick thing about good, bad, and ugly, because I always tell people that we're teaching people the wrong thing. We teach them to type their manuscripts in tech. We teach them to talk Fortran, whereas most of your employers out there want something quite different. They want Excel, Java, all the goody things that we buy a PC for, unless you buy a Mac. Astronomers are very good at detecting things. The revolution in astronomy that has taken place in the last 30 years, and it has been a revolution, has been driven largely by technology and by detector technology, which indeed did come out of the military-industrial complex. It's now coming back slowly into the public area, but one area, of course, is where you have these CCTV cameras, which are all based on CCD chips. Your still cameras are mainly based on CMOS chips, but that's for a different technical reason. And now we have new things called, which you've never heard of, called EM CCD chips, which I think will be very important for astronomy as well. And companies like Samsung, which you all know because you all buy these great big plasma screens, 2 meters across, with the word Samsung written on the bottom, they're producing a camera which does this. Believe it or not, this is 2 pictures of the same scene. One camera is higher than the one. The black one is a regular camera that you see everywhere around that you might use to take your home movies. The one on the bottom right is basically one of these new EMCCD cameras. Now, in the industry I work in, which is largely to do with video taking and things, the ability to do things at night in the dark is extraordinarily important. The only problem I have with the one on the bottom right is the noise is very hard to deal with because it's manifestly non-Gaussian. That's a kind of a technical point. But here, in fact, I can see on my screen, there's a door on the right. I can see that there's a door on the right there, and I can't even begin to show you. The door is here. All right? This is almost 1 million times more sensitive than the regular one. And hey, it's astronomy. There's a wonderful website by Craig Mackay about these EMCCD cameras, and they're coming into the public domain. They're quite expensive, and unlike the thermal imaging cameras that you've heard, they use simply glass lenses. They don't require lenses made of solid germanium, which is, I don't know if you've ever seen one of these thermal imaging cameras, but the lenses are something to behold, and they cost up to $100,000 each. The other thing we do is wavelet-based compression. The picture is Calatrava's architecture in Valencia. He's my favorite architect. That's why I use this. It has lots of lines in it. And instead of compressing video, you all heard of MPEG. You all use MP3 in your ears. MPEG-2 you have on your CDs and things. And now we're going to the world of MPEG-4. Hey, astronomers can compete with that and do better. We do, by a large factor. And although I sit on the international MPEG committees, I've got something different, which basically compresses images out of their mind with no loss in quality. Very little perceptible loss in quality. One thing this does is that astronomers, for example, take an immense amount of data. One of the things my company sells basically generates a terabyte of data per day, and on a site with 100 cameras, that'll be 100 terabytes a day, and we analyze all that in real time so people can search that data in a matter of seconds. There's a patent for this. We don't write papers. We get patents out and all kinds of things like this. And the issue is, this is pure astronomy technology gone straight into the public domain to analyze video in a live stream, coming out and make it accessible to other people. None of the guys in the military complex can do this, actually. It's quite fun. When you talk to them, they say, oh, impossible. No, it's not. I'm an astronomer. All things are possible to astronomers, I think. We start the equations. And what I want to do is just to show something that's going to surprise you. It's important to understand the reach that an astronomy training can have. And this is an extreme example. And if you're not into equations, just appreciate them for their architectural beauty and not their content. And if you are into equations, you'll recognize what it is and you'll wonder why on earth I'm showing something so trivial. And the point is, we believe that cosmic structure originates out of irregularities in density. If I can find my mouse, I can show you that there, these wiggles. And the high-density wiggles become galaxies. The very big wiggles become galaxy clusters. And we're challenged to find the mass function of galaxies so that when you look through your telescope and count the number of big galaxies, small galaxies, microscopic galaxies, you get the right number, and you compare it with the numerical models that I showed you right at the beginning, and you got the right answer, so you applaud and say, we understand the universe. This is a fundamental paper, and it's one of the most cited papers in astronomy this comes from, by Press and Schechter in the old days, probably the most cited paper in astronomy astrophysics. And this stuff, amazingly, just think, look at it, stare at it. This could be a stock market quotation. It could be the Dow Jones Index over the last, this bit, the first hump, could be the Dow Jones Index history over the past few weeks, months, years. I'm going to tell you why I believe these guys knew what was coming. Now, when I saw that, I thought, hey, you know, if that's the case, if I do treat this as a financial struct, how do I get into this? It's rather interesting. Astronomers, because of this breadth of teaching we give them, can get into every corner of the world. You know, we've shown you medical science, TV, video. Now we come to the financial world. Now, the most important paper written in the finance in the past 50 years was two papers, in fact, one written by Merton and one written by Black and Scholes. And Merton and Scholes, Black died, went on to win the 1997 Nobel Prize for Economics. It was then called the Swiss National Bank Prize in honor of Alfred Nobel. It has now become a real Nobel Prize. And this formula, which was invented in the 1970s, the papers were both written in 1973, has dominated the financial markets to an extent that you would not believe. And it is argued, there's a nice article in Forbes magazine recently, which is a magazine that we don't read, of course. Why would you? It's financial. Arguing that the present financial crisis is due to a failure of our financial models, and the financial models was invented by these two guys. So let's look at it in a little bit more detail. And the question they answered, what did they do? They answered the question in blue on the right, how much should I pay for coffee in 2010? Now, this involves all kinds of risks and everything like that, and there was always a risk premium. What these guys showed is that you could answer this question on the basis of a particular model, which is now called the Black Scholes model, precisely, with no risk. And, of course, these financiers hate taking risks. It's other people's money, but they want to make as much as they can and eliminate the risk. So what Black and Scholes showed was how to answer that question by solving the equation you see on the bottom left. Again, if you're not into equations, don't worry, just admire it, because we're all going to go broke and go to hell in the next 1 year because of that bottom left-hand corner. And the equation has an exact analytic solution, and so successful was it that they started selling calculators so that people could actually calculate the Black Scholes prediction. Now, the predictions were so good that they abandoned the calculators, and when they said, how much is your coffee, the person would then say, give you not the price that he wanted, but the price that you're about to calculate using the Black Scholes formula. So these financial derivatives, as they're called, they're ways that stockbrokers can make a lot of money without returning anything to society. They enable you to make bets on a terrible basis. So that's what it was. And the interesting thing is, this will blow your mind. The two formulae, the one for the mass function of galaxies is on the left, and the one for our economic fate is on the right. And there's a little transformation in the bottom left-hand corner which transforms the right-hand equation into the left-hand equation. Why? Why is it interesting? Well, it's interesting because every astrophysicist knows about this and every astrophysicist can do this. So we can all take a pay hike now by going back to the financial services people and say, we know better than you do how to do this. Our models are better than yours. And they are. And any astrophysicist who understood Black Scholes, which we don't teach, would have understood why this model was doomed to failure. And I think that there's a large fraction of young physicists in the United Kingdom. My own son just finished a physics degree with astronomy biases. He's going to go into the finance world. Why? Why not astronomy? Because he's going to earn a hell of a lot of money. And that's a fundamental thing that you cannot get around. However, he was trained in astronomy, and he built his own radio telescope as a part of his master's thesis. That was quite good. So, I'm just going to finish off with, since everybody's being very intellectual in this place, with some information from Plato's Republic, which essentially shows the sea change which has to have taken place in our view of astronomy and how we educate people. Socrates says, shall we set down astronomy among the subjects of study? Yeah. And Glaucon says, I think so. To know something about the seasons, months and years is of use for military purposes. Hey, that defined the pattern of astronomy for the next 2,000 years, as well as for agriculture and navigation, the good things. Socrates then says, it amuses me to see how afraid you are lest the people should accuse you of recommending useless studies. Socrates then goes on to talk about people, trying to make astronomy useful by adding the vulgar comforts of life to it. And unfortunately, nowadays, with the way our education system works, with the way our fundraising works, the Socratic model of intellectualism is no longer valid and should be abandoned. We do not live in ivory towers. So, in a sense, I think that the way I feel about astronomy is that it has to be seen to be useful. It has to be seen as a mechanism of education where people have a future, and I think it is the very best education. The thing we've got to do, my last sentence, is we've got to get the kids while they're young, get them to cut up their bicycles and say, hey, we want to do astronomy, we are not interested in particle physics, we are not interested in nuclear physics, etc., etc. And the job you people are doing, I think, is a wonderful job towards that end in this special year for astronomy. Thank you. there won't be issues.
We have time for one or two questions before lunch. Any questions? Yes?
I really love your talk, by the way. But there's another mode in which astronomy works with industry, which is as a leading edge customer, which you can go in there, take high risks, push the technology where a commercial customer wouldn't go. As I give you a case, I was involved in a particular project which cost $10 million, but the company actually made a factor of several times that in exports, having developed a technology which they considered they would not have developed had they not had these astronomers in there, not saying, we want to build this thing to this spec, but we want to see how well you can do. And that's not what normal customers do.
That's a very fine business model in one, but it's actually not that easy to get things. I think Janet gave a talk yesterday about having invented something and made it. There's then another nightmare, which is to get people to buy it. And I think that that's one of the business models. And the job of the changing financial situation that we all face is to change our business models to one which is likely to succeed so that our teams can survive the next year of hell. And in the UK, it's going to be a year of major hell. But yeah, thanks for the comment. Thank you.
We'll see. Yeah, I think, well, you have a quick comment?
Yeah. Well, just you have given a very straight motivation for why I would want to go into astronomy as a career and do something practical for humanity. In my talk, I'll address what to say to somebody who will not go into astronomy and still why it would be useful for them to do it. And there, I'm inclined to go back to the Socratic position and tell them it's good for you to know where you live. And
I actually strongly disagree with that.
Well, maybe that.
We should have an argument about it.
I think
that we need to be seen to be useful.
So there's a fundamental disagreement there, which is probably a good time to to go to lunch. So thank you very much for the session to all the speakers.